Okay, good morning. Coming to you live from the Jackson Girls Playroom. We're just going to get right into it here. Working on difference quotient. So we introduced this yesterday. We talked about how the difference quotient is a very specific, I call it a formula. Okay, call it a formula. It's not necessarily a formula that gives us a numerical output, but it's a format for doing something. Now, what this does and how this helps us, we're not going to talk about until we get to limits, which is down the road. All we're focusing on right now is how to algebraically simplify, how to write it and simplify it given any type of function. So the function that I'm going to do this for, I'm going to write it over here for a reason you'll see in a second. The function that we're going to do, zoom in if you have to, I've got a limited amount of space here, is x squared plus x minus 3. So this is the function, f of x, that we're going to find the difference quotient for, right? And we talked about how, let's see if I can get some of these different colors. I've got hot pink. There, see? This expression, x squared plus x minus 3, that is f of x. That's going to go here. What we have to do is determine what's going to go in place of f of x plus h. Well, we talked about this in class. If f of x is x squared plus x minus 3, then if this was a 3, let's say, this would be 3 squared plus 3 minus 3. If this was a negative 8, we would say negative 8 plus negative 8 minus 3. Well, if we make it an x plus h, I'm plugging x plus h in, and I have to remember to use parentheses around that, and I have to remember to plug it in for both of these, okay? Not just the squared x, but the x here as well. So I'm putting x plus h in here and squaring it, I'm putting x plus h in here. So when I write out this entire expression, and I'm gonna have to get crafty here, probably gonna have to erase this a few times. F of x plus h goes in first. Now this minus sign, let's see what else do I got in here. Got a blue? Let's see if blue works. No, Evie's not too good about putting the caps back on the markers. This minus sign right here is right here, okay? So here is f of x plus h. Now I'm going to subtract f of x, which is this statement. And because that statement has multiple terms, I'm going to put parentheses around it. So I have this entire expression written here, okay? After I write this out, I'm going to expand the entire thing. Now, because I'm going to run out of room here, I'm going to write this line down, then I'm going to have to erase some of this and go back, okay? But when I have x plus h squared, we talked about there's a way to expand that. There's a shortcut. We square the first term. We multiply these two terms together, no matter what they are. We multiply them together and double it. So x times h is xh. We double that, we get 2xh. Then we square this term. That's h squared. We've got plus x plus h minus 3. Now because I'm subtracting this and I put parentheses around it, I have to subtract every term over here. Minus x squared minus x plus 3. And that's all over h. Right? After we write this, after we've expanded the entire thing, the entire expression, the numerator, we look at all of the terms that are up here. And if we've done everything right up to this point, then anything that doesn't have an h should have an opposite in the numerator. What do I mean? X squared doesn't have an h in this term. I also have negative x squared. Okay? X doesn't have an h. I have its opposite here. Negative 3 doesn't have an h. I have its opposite over here. So every term that didn't have an h also includes its opposite in the numerator, and they're going to cancel each other out. So the x squared and the minus x squared disappear. The positive x and the negative x disappear. The negative 3 and the positive 3 disappear. And I'm left with just this statement. Okay? Now I'm going to erase this because I'm going to run out of room here in a second. All right? So what I'm left with, I'm going to write this up here. I've got 2xh plus h squared plus h all over h. And the nice thing here is the reason we want all of these terms to have an h, the reason we want that in the end is because I have this h in the bottom. And when we get to this, when we start talking about limits, this is going to end up being 0. I'll ruin the ending for you, but we'll learn about that more in May. This is going to end up being 0. So what we want is we want to be able to cancel this. And the only way we can cancel this is if we can factor it out of the numerator. And we can, because every term in the numerator has an h. So we factor the h out. Now when I factor an h away from here, I've got 2x. When I factor an h away from here, because it's h squared, I'm left with an h. When I factor h away from here, people make the mistake of just saying, okay, the h is gone, so there's nothing there, but really there's that coefficient in front of it. So we have to leave a 1 in place of this, right? If this was 2h and I factored the h out, there would be a 2 left over, right? We wouldn't just say, oh, there's nothing there now. This is a 1, this is 1h. So when I factor the h out, there's a 1 left over. Now once I have it on the outside, now that h is being multiplied times this. So I'm canceling that h with that, and I'm left with 2x plus h plus 1. That's our simplified difference quotient. We'll talk again. In May, we'll talk about what that means exactly. But for now, this is our simplified difference quotient. Okay? More to come.